Hi, welcome to my stream. This is going to be day 14 of Advent of Code, and I'm not going to forget today to transition over to my display. One of these days I'm going to figure out how to set different audio levels for different scenes in OBS, so that I can start the music at voice level and then have it fade down to background level when I start talking. I'm still new at this. All right, so let's switch over to I was doing my roguelike stuff yesterday. Let's do day 14. First things first, of course, is we need to set up our quick fix list cache so we don't struggle with that again. Let's see, and we're going to keep day 12 down at the bottom until I have a chance to optimize that solution. I've given it some thought, and I think there's a way to optimize it by just setting a flag and looping over the whole, recursing down the thing once, which might speed things up, but I haven't played around with it yet. But meanwhile, let's get this to do a check. How come it's not doing a check? There we go. Mictor day 14. Source day 14 mod.rs. Pub fun day 14, and just do that. Okay. Let's take a look at what day 14 has in store for us. Let's go to a calendar. Day 14. Day 14, extended polymerization. The incredible pressures at this depth are starting to put a strain. Oops, I need to do this before any spammers come into the chat. All right, we're good. Starting to put a strain on your submarine. A submarine has polymerization equipment that would produce suitable materials to reinforce the submarine, and the nearby volcanically active caves should even have the necessary input elements in sufficient quantities. The submarine manual contains instructions for finding optimal polymer formula. Specifically, it offers a polymer template and a list of pair insertion rules, your puzzle input. You just need to work out what your polymer would result. You just need to work out what polymer would result after repeating the pair insertion process a few times. For example, and then CB is the polymer template. This is a starting point of the process. The following section defines the pair of insertion rules. So AB to C means that when element A and B are immediately adjacent, element C should be inserted between them. Okay, so just to look at here, I see the first two characters NN, and then goes to C should mean that we go NCN. The first step simultaneously considers all three pairs, NN, NC, and CB. And then, so C is inserted between the first N and the second N, second pair. Note that these pairs overlap, right? So we're going to use the Windows thing that we learned about on day 1. Source, day 1, mod. We did Windows here, right? Yeah, Windows. So if we have an iterator, we can iterate over Windows of the, which will give us our NN, NC, and CB. Note that these pairs overlap. Second pair of 1 is the first element of the next pair, right? That's the Windows thing. After the first step of this process, polymer becomes NC, NB, CHB. This is a template, step 1, step 2, step 3. Okay, so it's actually, so yeah, if you disregard the first character, right, it's always going to be doubling in size. We're always going to add, we have NCB, which goes to CN, BCHB, right? So that 3 becomes 6, 6 becomes 12, right? And 12 becomes 24, 24 becomes 48, and then we add 1 for the first character. So it's, after step 5, it has length 97, right? 48 becomes 96, add the end at the beginning, and it becomes 97. After step 10, it has length 3073. After step 10, B occurs 1749 times, C occurs 298 times, and H occurs 161 times, blah, blah, blah. Subtracting the quantity of the least common element. Oh, taking the quantity of the most common element and subtracting the quantity of the least common element produces 1588. Apply 10 steps of pair insertion to the polymer template and find the most and least common elements in the result. What do you get if you take? Okay. So we're going to do the subtraction thing and get that. All right, so let's see if we can set it up at least for, I'm going to copy this over as test input. Test day 14 dot text. Paste that in there. And we'll go back here and we'll see if we can read it in. Do that. I don't know if I'm going to use a hash set yet. Okay. And we'll change this to test. And day 14. Okay, so our first line of sub-0 is going to be our template. And we want to split it up into pairs. What we could do is just make a vector and then loop over the windows. So we can do char equals lines of 0 dot chars dot collect. Can I do that? And then println just to see if this works. Template is this. Oh, it doesn't like that. Oh. Okay, run that. We got NNCB, so then we can loop over the windows. Let's try doing that. For W in template Windows 2, we can print out W. And so we should see NN and then NC and then CB. NN, NC, and CB. Okay. I think we're getting there. Now what we need to do is read in this. And what's the best way to do this? Can we do a new standard collections hash map? If we do a hash map that maps a tuple to a new character, a tuple of characters to a new character. So we can do is a hash map of a tuple of chars and a resulting char. So we're going to start on line 2 of the file. So let idx equals 2 while idx is less than lines len. What are we going to do? We're going to split once. Left and right is equal to lines of idx split once on that input. And now left is going to be, oh, what is the type of left? I think it's a stir. Yeah, it's a stir reference. So how do we decompose that into characters? I think we can say, can we do this? Let L1 equal, oh, we can do, we have to do chars.next on it, right? We have, let's set up a split chars equals left.chars. And, oh, it's got to be mutable because we're going to do a next because it's an iterator. We'll do L1 is chars.next.unwrap. And L2 is chars next unwrap. And then right is just a character. So we should be able to insert that directly into the mapping. insert L1, L2, and then write.chars.next.unwrap. And let's print that out and see what that looks like. Does this check? It does not. Oh, it has an option. Oh, right. This is an optional thing. So we have to do say if let sum, and then put the tuple in there like that. I forgot. We did that yesterday. And then idx plus equals 1. Plus equals 1. Mapping is not mutable. I'm going to forget that a million times. Okay, so that worked. So this says HB maps to C. Yes. HN maps to C. BB maps to N. And all the way down at the bottom here. NH maps to C. Where's NH? Uh-oh. Oh, there it is. Okay. So I think that mapping works. And now we need to apply the mapping to our template. And we're going to go for W in template. We're going to do this. We do this 10 steps. And right now we're just using the test input. So in 0 to 10, what we'll do is create a new vector, new template. Let's just call it new vec. Is a vector of char, vec new. And then as we go through our windows, we have window of 0 and window of 1. So we're going to look up, we want to push the first letter first, right? Because we want to change NNCB. We want to say we're going to get a pair of NNs, which we want to turn into an NCN. But in our loop, we want to push the middle one and the next one, I think. Because, so new vec push template of 0. Right, that pushes the 0th, which is the N, and then we'll push the mapping. We're going to look the mapping up for our two characters here. So let next char equal mapping get, and I think it's just W0 and W1, unwrap, and then we'll say new vec push next char, and then new vec push W of 1. And then W of 1 will become W of 0 on the next one, and we don't need to re-push that. Let's just do these 4 times and print them out and see what the vec looks like. And then once we've gotten the new vec done, we just say template equals new vec, println next is this. Okay. Oh, it doesn't like that. We can't push. Oh, okay. We can do that. Do a copy. Oh. Oh, okay. I was able to do it the first time because I just collected into it and didn't have to change anything. All right, so we have NCNBCHB. NCNBCHB, that works. Then NBCC and BBB CBHCB. Okay, so that's working. So let's do it all 10 times. And then what do we need to do? We have to get the most common and the least common. Okay. So we can just loop over the template and put together a hash map that maps character mut count. Yeah, I almost forgot again. Hash map, which goes from char to usize. We'll do C in template with the count of C, entry, C, or default, plus equals 1. Is that all we need to do? Yeah, it's just, all we're doing is counting each individual one, and then we say let min. We're going to have to loop over this array a couple times. Count iter min unwrap, and then max. Oops, didn't want to ax that. Println day 14 part 1 is this max minus min. That does not check. Wait a minute. Oh, count iter, count values. Okay, run. We got 4241, which is not 1588. Okay, so this failed. What failed though? We got the new template. I don't want to print out each one and then decide. You know what we could do is just print out this thing and see if it, how close we are or how far off we are with the counts. Maybe we're doing something wrong with the counts here. Oh, and now it works. Now we get 1588. What did I change? All I did was print out the count thing. C, B, yeah, all these numbers are correct. I'm going to take that out. Hopefully printing it is not the thing that makes it work. That would be sad. No, I'll get 1588. I wonder, what did I do wrong? That's strange. All right, so it's getting the right answer. Let's grab our puzzle input. How big is the puzzle input? Oh, not too bad. All right, let's save that. This is input day 14. Let's close that. Let's close this. Let's move it over. Downloads input day 14 into inputs. All right, let's give it a shot. Let's get rid of, we have other print line. We don't need the mapping anymore. Change this to input. Okay. So I got 2233. Is that right? That's the right answer. Okay, not bad. So this wasn't too bad of a puzzle. Let's get rid of that extra line. Let's check in with Clippy. What Clippy thinks. Clippy has issues. This is not helpful because I'm not emptying the lines. Oh. I don't want that anyway, right? I want to do oh. That's for day 13. I never did Clippy on day 13. Well, let's fix the day 14 one first, because there's one here. New vec push. Help consider using the vec macro. Let mut new vec char is vec ... Oh, okay. We can do that. That saves us one line of code. We can just say vec bang template of 0. Sure. That still works. And then Clippy should be happy there. All right, so we'll add that. Git add It's just this, right? Git add source and inputs, git commit gem day 14 part 1, and then we'll fix this on day 13. Day 13. It's not while lines IDX is not equal to quote quote. It's while lines IDX. No, while. Just yeah, the file had a blank line in there, right? Oh, that's right. We're looking for the blank line here and the skip blank line. Yeah, okay. So we can say is empty. Not is empty. Sure. And let's just rerun it just to make sure that still works. Yeah, so that still works. Okay. Kill. And so git status is just that one file. Git commit, clean up Clippy warning from day 13. Okay, so let us see what day 14 part 2 is. All right, the resulting polymer isn't nearly strong enough to reinforce the submarine. You'll need to run more steps of the pair insertion process. A total of 40 steps should do it. In the above example, yeah, look at these numbers. Okay, so we're not going to be able to build a string anymore. Ooh. We are not going to be able to build a string anymore. We're going to need to be smarter about this because we're not going to be able to store a vector of this length. So what can we do? Can we... This is... Yeah. Right. So this is one of those puzzles where you solve part 1 the naive way, and then he throws a loop at you saying, okay, now simulate the more atoms than there are in the universe. So you actually have to flip your thinking and say, okay, I'm not going to be storing the whole thing. I have to store a representation of the thing that we're trying to do. And that would be shorter. So I think, so let's take a look at what are we doing with these strings. We're going from NNCB, then we're generating n plus the bn, right? Because we're inserting the b. This is what we're doing up here. In this loop here becomes we insert the n here, and then this becomes bn. Right, and then we see NC, and that becomes the BC, right? Because we insert a B before the C. And then in between CB, we put the H, so it becomes HB. So this is what this becomes. And then on the next step, we have NBN, BC, HB. And that goes to... We get the n again. Right. And then for NB becomes... Oh, it's NCN. I made a mistake here. NCN. I was looking at the wrong thing. So NC becomes NB. Do we want to... Can we store these as a pair conversion? In other words, we have 3 pairs here. I have NN, NC, and CB. Right? And if we store it this way, we can say we have one of these, oops, and we have one of these, and we have one of these, and then convert. When we see NN, we know that NN becomes NCN becomes NCN, which means that we result in one NC and one CN. But then we have duplicate letters, right? If we're trying to keep track of everything. So then the NC becomes CNB. Yeah, no. NC becomes, yeah, CB, NCB, NBC, NBC, which is an NB and a BC. And then finally we have CB, which becomes, where's CB? HCHB, which is a CH and an HB. So then the resulting string is NCN BCHB. We have NCN BCHB. Right. So what we want to see after we do this is that the count of n's are, it should be, I see 2 in there, equals 2. Our c's equals 2. We have 2 b's. Yeah, 2 b's and an h. So if we store things this way, we can say, you know, how do we do the counting? If we store everything as a pair, right? I'm not saying store it this way. Instead of storing it as a string, just store it as pairs and counts. But then after we're done storing it as pairs and counts, we want to be able to count how many entries there are of, how many occurrences there are for each letter. Right, because if we store it as counts, you know, NC N B C H B becomes NC 1 NC, yeah, 1 CN. Let me put these together. I'm just trying to visualize it here, and it's not working. BC 1, CH 1, and HB 1. But we want to be able to say, okay, there's 2 n's, but I see, if you look at just the letter N here, if I'm going to do this, it's going to highlight everything. N. 1, 2, 3, there's 3 there. And if we look for just the letter C, 1, 2, 3, 4, there's 4. And there's only 2 C's here. And the problem with, if we say, okay, what we'll do is we'll just count the first letter of each one, that ignores the first letter, right? Because this is N, C, N, B, C, H, and then we have a B at the end that we're missing. And if we count the second letter of each one, we have C, N, B, C, H, B. So actually, maybe so we can do is count the second letter of each one, and then add in the template's first character, right? Because see, it's always an N. So we can always add 1 for that. Maybe that's the way to do it. Okay. So how do we store these as pairs and count-wise pairs, and then how do we transform it? Let's do step 2 manually. So this is what it should result in. And how many n's are there? There's 1, 2, and b's, how many? I see 3, 4, 5, 6. And c's are 1, 2, 3, 4. And the only other thing is the h is a 1. Right, so we have 5. Get the cursor out of there. 10, 13 characters total. 6 and 8, 12, 13. Okay, so I counted all those correctly. So let's see if we can do this a pairwise thing. So the NC becomes okay, let's do it from here. NC becomes NB and BC. So the next pair is CN. CN becomes CC and CN. The next one is NB. NB becomes NB and then BB. Okay, so that's 2 NBs and 1 BB. Okay. And then BC becomes BB and BC. So we have BB and BC. And then CH becomes CBH. So we need a CB and a CH. Oh, it's BH. Sorry, because it's CBH. And then HB becomes HCB. So we have an HC and CB becomes 2. All right. So now we're going to count the second character of each one. So for B's we have 1, 2. Oh, no. We have 2 of them because we counted it twice here. We have 2 here and 2 here. So that's the 6 B's. How many N's do we have? We have 1 plus 1 is 2. That's correct. And then for C's, we have 2 C's and 1 C. There's, 2, 1, and 1. That's 4. Okay, good. And then H's. Okay, so that worked. That worked doing it that way. And that way we could just store all the pairs. And there's a limited number of pairs, right? As opposed to atoms in the universe. So let's try redoing. We've checked in step part 1, day 1, part 1. Sorry, day 14, part 1. So we have all this code. We can always revert if we need to. So instead of the template being a vector of chars, we're going to change this to a vector, a hash map of pairs and counts. So let's change template back to non-mute, and then we're going to loop over that template using Windows. Template Windows 2. Now now we're going to create a new hash map. Mut. And what do we want to call this? Pairs? Is a hash map of pairs of chars to a usize count. Okay. I just want to see if for part 1, The most common was B and the least common was H. So if we get the N count incorrect by forgetting to add that extra 1 on the front, that won't hurt us, and we won't know that we forgot it. And that might be key for part 2. So let's just keep going and try not to forget that. So pairs of W0 and W1 or default plus equals 1. And before we go any further with this, I want to print it out to see if we have the pairs correct. And we'll just comment all this code out. Oh, I forgot to put the parens after our default. Let's see what we get for pairs. Oh, right, I'm still using I want to look at the test input. Oops. There's one CB, one NN, and one NC. Okay, so now what we want to do is write the code that takes it one step forward. So we still want the mapping. And now we're going to modify this code here so instead of doing a new vec, we're going to call it a new pairs. And it's going to be a hash map of char to char. Actually, there we go again. We can just say let new pairs is equal to pairs.clone. I keep typing pairs. All right, because we're going to start off with the existing counts, and then we're going to have to add in the new pairs. So we see NCN becomes, when we add NN, when we look at the pair of NN, we're going to say, okay, now there's going to be, instead of being an NN in there, the new string polymer becomes NCNCB after that one step. So we can see that what we need to do is remove the NN pair and add in an NC and a CN pair. So we need to loop over the pairs. What are we going to call this? Tuple and count in pairs. And instead of doing all this stuff, what we're going to do is subtract. We need to subtract the count from new pairs. New pairs. Get unwrap, unwarp, minus equals count. And I think we put a star in front of that. So that removes the count from the new pairs, and now we have to add in 2 new counts. So new pairs entry. What's our pair? So this tuple contains the 2 characters, so it'll be tuple of 0 and we need the thing that we're actually inserting, and that's going to come from our map, right? Our mapping is going to have that. So let insert it equals mapping.get of our tuple. Unwrap. So our entry of tuple 0 and the character we're going to insert, or default, plus equals count. I got Paris on the brain here. Okay, and then this is going to be insert and tuple.1, or default is plus equals count. And this all goes away. We also want to then say pairs equals new pairs. And now counting changes, right? Counting, we're going to change this to pairs. And we're only going to count the first, well, we're going to count the first character of our template here. Template of 0. So let first char equals template of 0. We're going to save that for counting down here. Count entry first char, oops, or default plus equals 1. And then we're going to look at the pairs and pairs dot keys, right? Because those are our tuples. Oh no, we need both. We need the counts. So we need the key val pairs. And what we're going to do is we're going to say count dot entry of key dot 1, right? Because we're only counting the second letter of each one, and we've added the first character here. Or default plus equals count. Oh, we don't want to call it count. We called it value. And then get rid of this closing thing here. And so let's see if, well, does this any of this check? Of course it doesn't. Expected char. So let's put it that. Oh, I forgot to put what to get. We want to get the tuple. I guess we do that too. What's next? Insert. Doesn't like insert. Where's the insert here? Oh, okay. I've got to star that. What else? Or default. I keep forgetting the parens after all default. All right, let's rerun that. There's another one. And it doesn't like this. Can't assign to data in an ampersand reference. Get mute. Okay, so that checks, does it come up with the 1588? It does. So that worked, which means now part 2, we just give it our input here and hope it doesn't blow up. Oh. So part 1 is 10 times. Right, I forgot that part 2 needs, so wait. I forgot to see what that number was. I wanted to verify that it was 2233. Let's try running it one more time. But now I need to run it 40 times, which means I need to run it 30 more times and get the values. Yeah, 2233. Still works for part 1. Let's get rid of all of that. And then we're going to have to redo this. Maybe we can make this a function here. Function get counts of pairs, which is a hash map from char to usize, and we need the first char, which is a char. And then this just returns max minus min. And up here, we just call it get counts pairs first char. Does that check? It doesn't. I forgot to return a usize. This should still be 2233. It is? Okay. So then we're going to do this. loop. And this is going to be sloppy, but that's okay. We'll do it 30 more times, and then print that out because I just want to get the day done, and then we can refactor. It doesn't like that. Oh, I moved it here. Okay, I don't want to move it. I just want to reference it. I was wondering what was going wrong. It took me a second of silence. Wow. There we go. And this is a reference. That checks. Run this. Day 14 comes up with a huge number, and we can only assume it's correct for a few seconds longer. And we now know it's correct. Yes. Okay. That was a tough one, and that was a fun one to solve because we had to rearrange our thinking to keep track of pairs instead of just generating the full string. Now, can we clean this up? Let's try, since we have a little bit of time. Let's just extract this out into a, oops, like this. Run loops. We'll say pairs gets a hash map of char and usize. And we don't care about the first char now, but we do want to know loops like that, and it's a usize. And that's going to return a hash map of char to usize. Open. And this just gets a loops. And then we can just return pairs. Like that. And of course it doesn't work. Oh, because we've got to pass in our mapping. Mapping. What is mapping? What's the type of mapping? Char. Let's put that here. And then pass the mapping in here. Oh no, we need to pass it in for run loops. So this is going to be pairs equals run loops pairs mapping 10. And then we do another 30. And we get rid of this thing here. Expected reference found struct hash map. Okay. And we want to do a reference here as well. Oh boy. Expected struct hash map found reference. I thought I just put the reference here. Oh, I put the reference in the wrong spot. Oops. Like that. Expected reference found struct hash map. Oh. We will clone that up. There we go. And we're now doing shadowing. So this pairs is a different pairs. And then we can just return that. And let's see if this gives us the same values. I'm guessing that is the right value. Well, let me just really check my personal stuff. Oh, look at that. I cracked 15. Oh, sorry. I cracked 20 again. Came down to 15,840. All right, my next goal is to crack 15. Yeah, this one must have been a tough one because not as many people solved it. So let me look at my numbers here just to double check. 2233 I remember, but this number I can't. That looks, yeah, 2164 at the end and 2884 at the beginning. Close enough. All right, so the only other thing I want to do is clean this up a little bit by saying type pair map. Pair list is equal to hash map of char and char to usize. And then type of mapper is hash map And this is just to make the code look a little nicer. And then wherever we have a hash map here, we can replace it. This is the usize one, so this is a pair list. And then we're gonna this one here, so that just becomes pair list, and that becomes pair list. And then this guy becomes mapper. Is what I called it? I forget now. Oops, I forgot to change that one. Yeah, mapper. So that's a mapper. That's a separate one. And this is pair list. Okay. That just makes the code a little easier to read, I think, without having all those extended hash map things in there. It still checks. The only other one is this one, and this I think I can live with without creating a brand new type for it. All right, let's see what Clippy thinks of our code. Oops. Clippy likes our code. Git status, git add source, git commit -m day 14 part 2. Done. Git push. All right, we now have it up on GitHub, and we're all happy. So the only other thing I wanted to do, now that day 14 is done, let me check our leaderboards. See how my my compatriots are. Oh, look at that! I'm up to. Oh, was I in third yesterday or something? I forget where I was when I checked it last. I am all the way down on 11. Yeah, this one, not as many people are solving it this time. Okay. Toggle bit. Yeah, I'm up at 7th. That's not bad. Prime. Where am I? Way down. Yeah, 32. And then, he did not do. Oh well. I enjoy his videos. He posts videos with Haskell solutions, and he does it in a very a teaching way, right? He explains how Haskell is working. I still don't understand Haskell, and I've been watching his videos for a couple of years now. I kind of get the syntax, and once in a while I'll understand what he's talking about, but Haskell is a little beyond me. Yeah, okay. Not too bad. What I wanted to do actually was modify our main so it only ran today's puzzle unless you gave it an argument. And so this will give me an opportunity to learn how to process arguments. And I think it's called standard env args. Yeah, args in standard env. And the way you do it is for argument in env args. So the first thing I want to do is index into this thing based on what day of the month it is, if it's December, right? So I want to say, if December, then just run that day's puzzle, unless -a is on the command line. Otherwise, run all. Or if a number is an argument, run just that day. Otherwise, run all. Else. Wow. And there we go. Okay, so this is the logic I'm going for, and let's see if we can do it. So the first thing I want to do is put 14 back where it belongs, or 12, sorry, back where it belongs. And then I want to be able to, let's do the first one first. So we'll comment these guys out, and we'll say, how do we get the get current day? Rust get current day. How do I get the timestamp of the current date and time in Rust? Oh, I have to use a chrono crate. Date and time, Rust cookbook. Yeah, it looks like you need the chrono crate. Okay. I'm reluctant. I always am reluctant to put in. Let's open cargo.toml. I don't like adding lots of dependencies to things, but 0.4. It'd be nice if this was like a 1 dot something. Why is it 0.4? What's missing from it? Okay, so we get that crate in there. And then how do we use it? Chrono offset local now. Well, let's look at the docs for it. Right, features, standard time, system time, date time. We can get the use. This is converting it. How do we convert it from the current time? This date time local is local now. And then what can we do with the date time? Does that have a get day? It returns a date. This is more complicated than I thought it would be. This is harder than the advent of code we just solved. All I want to do is find out what the current day of the month is. All right, look, I added the chrono thing. How do you get the current year and month from chrono date time? There we go. I don't want UTC, but we can do local, right? We can do chrono local now. Let now equals chrono local now. And then we can just say day, right? Println today is, and we'll say now dot day, now dot month. And this is going to give us a million warnings because we're not using days, we're not using anything in here. That's right. I don't care. Oh, it's not there. The method is available for here. Oh, but I need to import the trait. Use chrono date like. Okay, there we go. We can add that up there. No problem. 3 warnings. Okay, I'm not going to worry about the warnings, but if we run this, do we get a day and a month? Of course, chrono has dependencies as well. 14/12. So today's the 12th month and the 14th day. Perfect. So we're going to say if now.month equals 12, then we're just going to run days of now.day minus 1, like that. And that's all we need to do. Oh. As usize. I don't know what type it was. Okay, so if I run this now, I should just get today's, yes, perfect. We still want to do this, oops. I keep quitting out of the wrong window. We still want to time it. Put that there. Just get rid of all of that. Cargo check. What? Oh, I'm doing the wrong. I'm doubling up on now here. Today. It's today, and this is today. Okay, so now I can run this and get the completion time for day 14. So that's the first half of this thing. Now we want to say unless dash a. So dash a will always mean run all of them. So now this is where we want to look at the arguments. So we can grab the first argument this way. Can we say, we'll say use standard env. And now I want to just grab the first argument here. This is we have to loop over it. Can I say let args equals env args collect? Can I do that? Is there an easier way to do this? Args like that. Let's run that. Consider giving args a type. Vec of strings. No, it didn't mind that. Okay, so there's that. So I should be able to say cargo run and just say dash a, and we should see the dash a. Oops. Yeah, and there's the dash a there. So we can say, there's probably a good args parse thing, but I don't care. We can do that another time. We can say if args len is greater than 1 and args of 1 equals dash a, then we'll just run all of them. And that was our for loop we had from before for d in days. And we can copy this, paste it in, and modify the, oops, I meant to copy the whole thing. What am I doing? Y, Shift G, paste. Thank you. Else this. Probably missing something, right? If it didn't insert properly. All right, and then we're just going to say for D in days, yeah, this is what I missed. So then D, call D, this goes here, and this goes here. Oh, D in days, like this. Okay, so now I should be able to say cargo run from the command line and just get today's, or I can run all of them. Yeah, I don't care about day 12 anymore. Okay, so that's this part of it. So I think we did the first line. So the second line is else if a number is an argument, then run just that day. So now we're going to refactor this. Say if, wow, hitting F1. All right, so I want to shift these in and then shift this back because I want to say, oops, there we go, like that. Else, if let some day equals args1.parse of usize, then we're going to run just that day. Now we have a lot of duplicated code. That's okay. I'm going to refactor that in a minute. Get it working first, then refactor it. Today, we don't want today, we want the day passed in here like that. Oh, if let OK day. Okay. So now I should be able to say cargo run dash dash day 8. Yeah, and of course it's day 9. Day -1. And we're not doing error checking right now. So that's okay. Yeah, there's day 8. Okay. So now we want to do all the refactoring that we want to refactor. So we're going to extract out a function called run, and it's going to pass in a function which is going to be a fn, and oh, that's all we need. right? Because the function itself is going to do the work. We're going to grab this and then grab these lines and put them down here. Like that. Let's see if we can get this all on one line. That should be fine. And then all we need to do is say run days of today, blah, 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 like that. Right, that should check, and that should run just today's, day 14. It did. So then we can say this. All we want to do is say run of days this. Otherwise, for D and days, run D. Okay, so we should be able to say cargo run, get today, cargo run 8, and get day 8, and then cargo run all, and get them all. Okay, I think we've got a good system now. And now when I run tomorrow, we don't have to run all of the things. I can just say run, and it'll run today's. Perfect. This is exactly what I want. Let's clean that up. Let's see how what Clippy thinks. Get add source. It was just that, right? Oh, right. We added get add cargo. Sure. Git commit -m. Command line options to make things friendlier for dev. Sure. Git push. All right, so that's going to bring me to the end of this stream. We did day 14. Day 14 was I think, the second hardest one. Day 8 was the hardest so far, trying to figure out all those numbers and things. But this was definitely the second hardest one because you had to figure out the trick for getting, how many, what is that, 2 exabytes, or I can't even look at that. There's no way you're going to store that, so you have to figure out how to do it the quote right way to avoid that mess. But that was fun. That was a lot of fun. Okay. Thank you to Eric for doing all of this. So that's going to wrap things up. Let's see if there's anybody we can raid. Nope. Click the wrong button. Anybody to raid? Oh, Togglebit's streaming. Okay, let's go raid him. We did it yesterday, but that's all right. So let me pause my music. Pause my music. Thank you. And then let's go over to Togglebit's thing here. And we can listen to him for a few seconds. All right. Let us start a raid for them. But meanwhile, thank you very much, everyone, for watching and joining me here. The VODs are available if you want to see how I did. And I do upload them to YouTube for, quote, posterity. So let us start the raid. And I will see you tomorrow for day 15. Take care.